This lesson is on segment addition, bisectors, and midpoints. The first thing we're going to talk about is the segment addition postulate, and the definition says that given 2 points, A and C, a third point B lies on the line segment AC if and only if AB plus BC equals AC. So this is very similar to when we did angle addition, but now we're just working with the segment instead. So it's saying that if we have a segment AC and line or point B lies on the segment, then AB, this part, plus BC, this part, has to equal AC. So AB plus BC would equal AC. So the two little parts add together to equal the big part. So let's look at example 1. So if C is between D and E, so I've got I've got D and E, and that's a segment, and C is somewhere between them. DC which is going to give me 19. So DC is 19. And then they also asked me to find the other segment, CE. So I have 3 times 8 plus 1, which is 24 plus 1, so CE equals 25. And if I add those together, I do get 44, so my work checks out. Now I want you to try example 2 on your own. So if B is between A and C, and AB equals 1/4 times 6x plus 24, and BC equals 7x plus 15, and AC equals 120, find AB and BC. All right, so first let's draw our diagram. We've got A, B, and C on a segment. AB is 1/4 times 16x plus 24, and BC is 7x plus 15. Now if I want to make this easier, I can go ahead and distribute that and say, okay, AB is actually 4x plus 6. And I know that the whole segment AC is going to be 120. So I'm going to have 4x plus 6 plus 7x plus 15 equals 120. The next thing we're going to talk about is segment bisectors. So this is the same, like a very similar concept to an angle bisector. So it's a line rear segment that divides a line segment into two equal parts. So if I have segment AB, it's bisected by C, this portion and this portion have to be equal. So AC would have to be congruent to CB. So looking at example 3, EF bisects AD. So I have segment AD, and it's bisected at point C. AC is 5x minus 8. CD is 16 minus 3x. Find the value of x and the value of AD. So the first thing I have to do is find the value of x from these two equations. Now, because it's bisected at C, I know that 5x minus 8 has to be equal to 16 minus 3x because AC and CD have to be congruent. So I'm going to solve for x. So x equals 3. But that's not all I have to do in this particular problem. It asked me to solve for AD. But in order to solve for AD, I'm going to have to solve for both of these angles. So or these segments. If I'm looking at AC, that's 5 times 3 minus 8. That's 15 minus 8, which is 7. If I'm looking at CD, 16 minus 3 times 3, that's 16 minus 9, which also equals 7. Now, I didn't really have to do that work because I know that if this one equals 7, this one also has to equal 7. Now, I'm going to find AD by using segment addition. So I know that AC plus CD has to equal AD. So AD is going to be 7 plus 7, which is 14. Now I want you to try example 4 on your own, and this one says that EF bisects AD at C. So we're going to draw the diagram. So A, D, C, E, F. So I want you to try this one on your own, and then we'll go over it. All right, so looking at this, I know that AC is 2/3 times 4.5x minus 1.5, and that AD, so the entire thing, is 12 minus x. Well, I know that because EF is a bisector, that these two sections have to be congruent. So if AC is 2/3 times 4.5x minus 1/2 or minus 1.5, this is also 2/3 times 4.5x minus 1.5. So I'm going to go ahead and simplify these. So I'm going to distribute that, and that actually ends up being 3x minus 1. So I've got 3x minus 1 times 2 equals 12 minus x. And I multiplied that by 2 because we have this one and this one. It's just easier than adding it twice. So that's 6x minus 2 equals 12 minus x. Now I can go ahead and solve for x. So x equals 2, but it wanted me to also solve for AD. So AD is 12 minus 2, or x, and that would be 10. The last part of this lesson is going to be talking about midpoint of a segment. The midpoint is just a point on a line segment that divides it into two equal parts, or the halfway point. So if I have segment AB and C is the midpoint, then this part is equal to this part. So it's kind of the same thing as a bisector, only it's a point instead of a line or a ray. So let's look at example 5. It says that M is the midpoint of PQ. So I have a line segment PQ, and it says that M is the midpoint. So PM is 1/2 times 10x plus 16, which is just 5x plus 8. And PQ, so the whole segment, is 76. It wants me to find X and PM. Well, I know that if PM is 5x plus 8, MQ also has to be 5x plus 8, because a midpoint is going to divide it into two equal parts. So 5x plus 8 plus 5x plus 8 equals 76. So that's 10x plus 16 equals 76. So then x equals 6. Now I'm going to take it and plug it back in to this equation to find PM. So 5 times 6 plus 8 is 30 plus 8, which is 38. Now I know that also MQ would have to equal 38. Now I want you to try example 6 on your own, and then we will go over it. All right, so example 6 says that M is the midpoint of PQ. So again, I've got segment PQ with M as a midpoint. PM is 9x plus 3, MQ 11x minus 17. And it wants me to find X, and it wants me to find PQ. So the first thing I'm going to do is find X. And I know that PM has to be equal to MQ because it's been bisected by the midpoint. So I have 9x plus 3 equals 11x minus 17. So 3 equals 2x minus 17. And 2x equals 20. So x equals 10. Now, in order to find PQ, I'm going to have to plug that x back into these equations. So 9 times 10 plus 3 is 93 for PM. And 11 times 10 minus 17 is 110 minus 17, which is also 93. And again, I didn't really have to do all of that work, but I just wanted to show you how it works. And then 93 plus 93 is 186. So PQ equals 186.